going to talk to you today a bit about Redis and why I think it's a pretty cool piece of technology. First of all, does everyone here know what Redis is? Or okay, it's probably going to be a pretty boring talk for most people then. Yeah, basically going to talk about Redis, why I think it's cool, then a bit about an ORM that I developed, and some tips for running Redis in production for anyone who doesn't have much experience. So a bit about me. Previously, I've worked at a company called Digit Games, which is actually where I had most of my Redis experience. And before that, I worked at Demonware. There's a few Demonware people here today, I think. So, but now I work at a company called PageFair, and we actually have a stand outside. So come talk to us. We have like some prizes with like Raspberry Pis and stuff like that. If you answer a few Python questions, you might win something. So come chat to us. But today, I'm going to talk about Redis. The ORM I was talking about is called Redact, and yeah, a bit about production problems. So yeah, a lot of people, I guess, have heard of Redis, maybe don't know exactly what the story is with it. Basically, it's a noSQL key value store where everything is stored in memory, so keys and values are both stored in memory. So there's some things like React, I think, stores keys in memory, so you're limited by memory a bit there. But Redis, you're like entirely limited by memory size. Just very different from like SQL or something. It has multiple different types of persistent options. So like you can completely disable persistence and use it as a memcache replacement, essentially. Or you can get very strong guarantees that everything you write will be written to disk straight away, and like a few different things in between. And there are data structures available, so you have like the same kind of things you'd have in like a programming language. So you have like a list, dictionaries, sets, and sorted sets, lots of options. It also has pub sub, so you have like a one-to-many relationship, so you can do things like trigger a deploy or something like that. Lots of different use cases for that. There is failover built in, so you can get high availability with a thing called Redis Sentinel. And also now has clustering support, so you're no longer limited by the memory size of one node. You can basically have the same key value space with up to 1,000 nodes. So pretty cool nowadays. Lots of companies are using it. I think I read some stats on Twitter using it. They had something like 10,000 instances of it or something. It's pretty wide-scale use in most companies for different reasons. I think a lot of people just use it as a cache, but it can do a lot more. So what's good about it? It has probably the best documentation of any open source project I've ever seen. Really good. It gives really strong performance guarantees. In the documentation, it tells you the big O notation of every single operation. And it's very clear when things can go wrong and how they might go wrong. Really good. It's also really fast. Very good benchmarks available online. You can do it. You can tweak it so that it's as fast or faster than memcached. There's a lot of language support, so pretty much every language I've ever used has support for it. Even things like Rust have fairly good support now, I think. So yeah, it's pretty good. It's very stable. So the major version I think bumped recently enough to 3, but it was at 2 for like years and years, and very backwards compatible with old features. And in general, never had much of an issue with Redis. Always been like OS difficulties. Also, it has good guarantees on atomicity. So basically, every write in it is going to be atomic. Basically, any operation in it is going to be atomic. And also, you can do transactions over multiple operations. So you can say that a group of atomic operations have to happen at the same time, or else you want an error to happen and roll back. So what's bad about it? I guess the main limitation is your memory size. So same as memcached, like you're limited to memory, but in reality, you're even more limited than that, because if you're using persistence model, you're going to want to be around maybe 50% utilization because of the way it forks the process to persist it to disk. So yeah, that's quite limited. You're also limited to having one core per process because it's a single-threaded C application. It's very fast, but it's not parallelizable. So basically, you can have multiple Redis instances on the same box and utilize the CPU to its fullest. But by default, you'll only be able to use one core. It's also schema-less, so it's the same as any NoSQL solution, I guess. You're not going to get any guarantees that the data you put in is of a certain format. So this is like an advantage or disadvantage, depending on how you look at it, I guess. So yeah, as I was saying, a lot of people use Redis just as a replacement for memcached, and it's perfectly valid to do that. It is basically just a better memcache in lots of ways, but some people are using it for queuing systems as well. So Celery has a backend for it. I know there's a lot of Redis-only queuing systems that have come out for Python as well, which are pretty good. A lot of the primitives lend themselves to queuing up tasks or performing things in a distributed fashion. So it's pretty good. And also PubSub, which loads of applications for, but a simple one to think about is if you want to trigger a deployment to happen on a bunch of machines, you just have to publish a single message to Redis, and anything which is subscribing, so all of your nodes, would immediately execute their deployment, say. So it's pretty good as an orchestration mechanism. But what you won't hear many people talk about it is using it as a primary data store. And going to talk a bit about why we did that and how it worked out for us. So for some applications, Redis actually suits really well as a replacement for your main database. So take online games as an example, which is the example we had. So you have a relatively small data set for the amount of users you have. You need absolutely the lowest latency possible. So the user experience is driven on the database basically being fast. And also you need transactions, just so that say you attack a player and it doesn't go through, or it goes through and is inconsistent, that's going to throw a lot of people off the game and immediately rage quit. So yeah, you need to be very, very consistent. So Redis provides pretty much all of these use cases very well. So we checked it out in Python, which is what we were using for this MMO. And yeah, it's pretty cool. You can get up and running really quickly. Just open an interpreter and start setting values, and it's great. The redact-py library is really good. We had a problem though. So we really liked using Redis. So we tried it out for a day, just writing simple applications. But then we realized we had this big lump of legacy code which used an ORM. It was actually using a MongoDB ORM called Mongo Engine. And we had a bunch of code that was dependent on this and the relationships between objects. And we didn't really feel like writing the whole logic of the game from scratch and removing a lot of the guarantees of relations and that kind of thing. And also, we didn't want to have to write serializers and deserializers for every single object we had in the game. So we decided to implement our own ORM, which had all of these properties. So the ORM we developed is called Redis Engine, and it's an in-house library we developed at Digit. And it has a lot of features. So it has transactions, data structures out of the box. So it has a way of running a Python function, and if someone else has modified something you wrote in that function, it'll roll back automatically and retry that transaction, which is great for us. And it has data structures, so you have like lists, sorted sets, sets, that kind of thing. Objects were all stored as message pack data, so basically we took the Python object, message packed the data, and inserted it at a single key in Redis. Yeah, that worked pretty well for smallish objects. When it got larger, it got a bit unwieldy. So like to change even like one tiny property, you had to like write a bunch of data to Redis, which is not great, but it suited us well at the time. Also has support for Redis Sentinel, so that's the high availability solution that I was talking about. So this basically lets you automatically fail over to a slave process if your master goes down for whatever reason. So you can have pretty good guarantees that your database is going to be up all the time. So yeah, we used that in production for about 18 months. The problem was when I left Digit eventually, I couldn't use this anymore because it was proprietary. So Stallman does not like. Over the past few months, developed an open source Redis ORM called Redact. With similar feature sets, kind of used a lot of the learning from the 18 months prior into the design. So instead of storing objects as message pack data, I store them as Redis hash sets, which means that when you modify one like single property in the Python object, you only have to write that single property. You don't have to write the whole object to disk again. So theoretically, it should be a lot faster for big objects anyway. Has migration support, so you can have like a list of functions that will get executed, and it will migrate the data from one version to another very easily. And yeah, that's pretty much it. It has transaction support. This is actually even easier than it was in Redis Engine. You add a Python decorator to the function you want to be transactional, and it will automatically delay any writes or deletes until after the function executes, and it will retry the function if there is a transaction problem. Has data structures built in. For this, I went for more Pythonic kind of data structures. So where there was a mapping from a Redis data structure to a Python one, I tried to keep it as similar to the Python version as possible. So keep it quite high level rather than the low-level Redis library. And also gives you remote fields. So you can, say, have a person class which references another like sale class. So it's quite nice. You can build up quite complex relationships this way. So 3 of the design principles I had when I was making it. One is that I wanted it to be as explicit as possible. So that was every operation that was performed that had like database impact is very explicit. It's like loads and deletes and saves. It's not like hidden in the background somewhere. Also wanted to minimize the amount of boilerplate you had to write. So any kind of serialization or transactions you would normally have to write manually, just like put that aside and give the programmer control to override this if he wants. So basically give them a very, very low-level API, which will let you call Redis directly if you need it. So here's an example of like object you can create in Redact. So it's pretty straightforward. You have a base model class you need to inherit from, and then you need to create these key value fields objects. And it will basically, when it's serializing and deserializing, it will go through the members of that class and automatically know that the key value field needs to be serialized with a key n and with the JSONified version of a name. So that works pretty well. So once you have the class definition written, you can very easily like create a prisoner, for example. So it's like 2 lines, and then you can load it, which is another 2 lines. So creating and loading is very similar in this model. So it's pretty straightforward. It's pretty explicit, I think. So that's a basic usage. Then there's transactions. So basically, you have this redact.transaction decorator. So that's all you need to add, and then it's automatically a transaction now. So these deletes that are happening down here are going to be delayed until the whole function finishes. So you can be sure that both prisoner 1 and prisoner 2 are going to be deleted by the time the function completes. But if someone else modified prisoner 1 in the meantime, it will retry, and only when you have the full length only when you have control over those objects for the full length of the function will it let you completely delete them. So it gives you good guarantees for data that's shared often. So talk a bit about the data structures that are available. So as I was saying, I tried to make these as Pythonic as possible. So they should be fairly straightforward for most people. So a sorted set is actually something that doesn't really have a strong Python connection. It's essentially a set where you can add a score to every key in that set. So basically, in this example, you give the number 6 a score of 6 and number 1 a score of 1, and that way you can query a range of scores like very efficiently. So you can get like scores from 0 to 5. You can get all of the elements there. So it's basically like a way of creating indexes in Redis very easily. So another example that we use this for is sorting by timestamp. So if you had a bunch of entries that needed to be processed in order, you could insert the value as the thing you want to process and the score as the time, like Unix timestamp. And then you can query for timestamp ranges and lots of cool things. You can trim by timestamp ranges, and it's very, very cool. Then there's lists. So pretty similar to Python lists, except you can, I tried to keep the terminology similar to the Redis API as well. So lpush is pushing from the left, and rpush is pushing from the right, and then you can pop from either side as well. And they're all O1 operations, so it's all pretty straightforward. Hashset is a Python dictionary, essentially, that every time you write a value into, it writes it into a hashset in Redis. It's not really that much to it. It's pretty much one-to-one mapping, which is cool. Then there is a redact.set, which has pretty much the same functionality as a Python set, except the difference being that the difference has to be a difference update because it has to be written into Redis. That's just a kind of style choice I made. I didn't think it made sense to have a difference and intersection which didn't write to Redis. So that's pretty much the data structures covered. And then there's also escape hatches. So if for some reason the high-level API doesn't cover something, you can get access to the lower-level primitives. So you can like manually set and get objects. Yeah. So the performance, pretty okay. It's like you can do about 10,000 writes in under 2 seconds on my desktop machine, which is about maybe 4 or 5 years old. That's with writing to disk, so it's not too bad. There's obviously going to be some overhead over the standard Redis library because that's what I'm using under the hood. But it's fairly minimal. Like for most applications, I think the overhead is pretty acceptable. It's definitely less than the other ORM that we were using before for Mongo, which had pretty crazy overhead for every operation. But yeah, it's pretty good. Even on my like laptop, which is like about 10 years old, it's not too bad. So yeah, it's up on GitHub. It's MIT licensed. You're welcome to use and contribute to it. Has pretty good test coverage, and it's pretty small, so it's very easy to understand. Even if you were thinking of writing your own ORM or something, it might be good to look at. But yeah, please, if you're interested in Redis, have a look and let me know what you think, or add stuff if you want. So yeah, talk a bit about production use of Redis. So yeah, there's some things you should keep in mind when you're using it. So if you're using persistence, there's two options available. There's the thing called RDB snapshots, which basically takes a snapshot of the whole memory and it compresses it and then writes it to disk. So this is quite good if your data set's very small and you just want like nice, easy backup at all times. But AOF is much better because it basically writes every operation to appends to a file, and then periodically it will squash the file into its smallest form. So this gives you better guarantees on data not getting lost, and it also is much faster generally. The RDB snapshots, I've noticed, will cause the process to sometimes stall from accepting writes. And yeah, if your workload is fairly write heavy, it's going to slow you down essentially. Yeah, so Redis Sentinel is really good if you need it. Like if you're happy enough that sometimes your node might go down, then it's okay. But like yeah. For most applications, you definitely want some sort of high availability there, and Redis Sentinel is really good. Redis cluster is also really good. If your data set is large, there's a bit of extra work you need to do to get it running versus normal Redis. You need to partition your keys, so you basically need to shard up your key space. So you need to think about that a bit, but it's very straightforward. And if you use it as a cache, you can disable persistence because that's just going to cause you problems down the line otherwise. Yeah, watch out for memory usage. As I was talking about earlier, there's that 50% threshold you should be monitoring. Otherwise, AOF compaction will start to fail. Yeah, I've noticed it when it gets to about 70%, it starts to stop working, and then it'll basically keep appending to that file until the file gets bigger, bigger, and bigger, and then eventually it's just going to like start breaking. So yeah, don't do that. Allocate more memory than you think, and set up lots of alerts. And if you have a pretty beefy box that you're using Redis for, there's no harm in using multiple processes and sharding up your data that way, especially if you're using it as a cache. It's a pretty easy way to get lots of performance out of it. And for read-only operations, you can use slaves, and Redis Sentinel actually makes that very easy. You can basically grab the list of slaves from your connection object and choose one at random to do your read-only operations on. So it's a good way of load balancing your nodes and also limiting the amount of things that are happening on your master node. So yeah, that's pretty much it. It's a pretty short talk, but yeah, hopefully people have questions, and yeah, I'd love some feedback on Redact for anyone that's interested. So. Please contact me on Twitter if you're interested. But yeah, thanks. Yep.
Is Redact Python 2 or Python 3?
Python 2 probably works in Python 3. I haven't tried it, but there's nothing that wouldn't work, I think. Maybe the strings I need to convert.
So transactions, are those pipelines or is something else going on?
Yeah, they're actually similar. So you don't need to have a transaction for a pipeline, but transactions are implemented over pipelines. So, sorry? Exactly, yeah. So it basically forces all of the writes to happen in one go. There's also another thing which is called a multi-exec pattern. So this will basically cause Redis to fail to complete the pipeline if one of the watched keys will change. All that stuff is kind of hidden from you here because the redact.load will do the watching and the deletes will delay the writes. So a lot of the details are hidden from you here. But yeah, essentially that's what's happening. Yeah.
Any comments on network latency? If you have a few servers and you want to put your data out with your servers to minimize network latency?
Latency is, yeah, it's pretty good. Like it's running over TCP, so like there's a little bit of overhead, I guess. Like it's very fast at responding. The only time it's ever going to be slow is when your network is slow or if it's very, very overloaded. It's generally very fast at responding to reads. If it's very write heavy, your reads are gonna be slowed down. So if you have a good mix of read and writes, you definitely want to think about having a master-slave setup and splitting your reads to the slave so that the master is set up to do the writes, because the writes in Redis are much more expensive than the reads, and you're going to be just delaying lots of reads otherwise, and also writes. But yeah, like I'd say sharding is the way to go if you want like best latency.
Hi, just a quick question, just more of a clarification question than anything else. Is Redis a database technology where persistence is optional?
Yeah, exactly, yeah. So essentially, it's a middle ground between memcached and a fully featured database. So as I was saying, like a lot of people just use it as a cache. So it's a very simple key value cache and disable persistence because they just don't need it. But it does have a lot of persistence options available to you. So yeah, like the persistence is optional, but they strongly encourage you to have it on, and it's on by default. So yeah, that's pretty much it. No more questions? Oh, yeah.
Just on the transaction decorator that you showed?
Yeah.
All the database interactions get queued up at the end.
The writes do.
The writes,
reads happen straight away, and they add a watch on every key.
Is there a way to choose not to execute the writes further down the function if you just reach a piece of logic where you decide you don't want to?
There is, yep. There's a specific exception you would throw.
Okay.
Actually, if you threw any exception, it would work, but if you wanted to retry the logic, say you got to a point and you were like, I know this isn't going to work, just retry it again, you can throw a specific exception. I think it's a redact.transaction error or something.
Cool.
So yeah, you can do that, or you could just throw a different type of exception and it will just bubble up. It won't ever execute the transaction.
Okay, cool.
Thanks very much. Cheers.